let's take a look at the book before we start with the interview. This is a book which I have, and I think Javier has actually a printed copy. I do have, in tradition, the copy of the book which we did the last time, which is a memory management book from Petrus Roy. So this book is about asynchronous programming with C++, and it mostly focuses on using standard C++ for this. And we'll go into the content now. No, that's the wrong page. Yeah, so okay, here we go. Table of contents. Let's quickly talk through this. Again, this book has part 1 to 4, and we're starting with the foundations of parallel programming and process management here. And
yes, so the first part is about the fundamentals, to try to introduce the reader on the different parallel paradigm that you can create when building a system, and also going a bit more into detail on how the processes and thread and services relate to each other. So, and from there, we move to part 2, that is where we start digging into the different libraries and functions that we have in C++ for multi-threading. So, by the way, this book covers many of the functions available since C++ 11. So many examples are valid for C++ 11, but we also use many features from C++ 20, even C++ 23 with generators. So we cover different standards, versions, but not only focusing on the latest, but also having a ground foundation on the earlier versions. I don't know, Juan, if you want to add something about the first part of the book. Juan, sorry, I can't hear you.
Okay. So yeah, that's the first part, which basically is on foundations, which you need to know about when you get started in parallel programming. And I like kind of that view here on page 16. I should say one thing is, like, when I go to page 16 here in my document, that's not the page 16, which is like in the index. I kind of have to add 20 to it or 16 to it at the beginning, and then you kind of end up in somewhere close to it. But yeah, so this is a parallel programming paradigms where you start, and then I think it's kind of important to have those things sorted out at the beginning. And
yes, for example, on that figure that you showed there, the seamed and mean, etc., also is a nice way to differentiate when the different function, I think is page 3 or 4, what? So it's a nice way to know the different systems that exist, and depending on the system that you are using your software, you have to adapt also the different asynchronous and multi-threading functions. Yeah, so the first chapter goes through the basic and the different kind of systems that you can develop, giving some ideas that later I explain more in depth in the following chapters.
True. Let's go back. And then we have the second part of the book, which is about, like, we're directly starting with advanced thread management after the foundations. So here we go into, like, how to create and manage threads with C++. And one part I found interesting is the thread local storage here, and then implementing a timer. So let's take a look at these. If I can find them, that should be, let's go for 83. That looks good. Yeah, so the book does contain a fair amount of code about various problems you solve in the code. But yeah, here we are with thread local storage. Would have been one more page. So Javi, what can you tell me about thread local storage?
Yes, so, well, this is a way to define global storage, but only accessed by thread. So you don't need to place any kind of synchronization mechanism if using another threads, because they will have its own copy of that memory, so that doesn't crash. And that's useful if, well, you want to have some specific area of memory available for each thread and do some calculations as we do in there.
Mm-hmm. And then we go into implementing a timer, which I think this is like always interesting to see the more advanced examples. That the book is here again using Chrono and mostly standard C++.
Yes, the only places that we don't use standard C++ is on the chapters about Boost.Asio and Boost.Cobalt, that obviously we use in the Boost libraries. Apart from that, all the other examples use standard C++ libraries.
Yep. Let's go for more chapters. So that's also something I liked in the book. Is like the chapter on synchronization. We have various locks in the language, but then newer features are latch and barrier. And let me see if I can find that. Yeah, here we are. So these are actually features which came with C++20. And what can I do with a latch?
Yeah, well, a latch is really a synchronization primitive that the difference with the barrier is that the latch is only one use, right? And it's a kind of a point where threads arrive, right? And they decrement the latch until the latch goes to 0, and then the execution can go on, right? It's like it's really very similar as a barrier, but you cannot reuse it, right? The example is just probably mostly the same. It's like adding something, and then when the threads finish doing the additions, then you can go on doing some other operation with the result or printing it and so on. It's a point of I want to wait for all the threads to finish their stuff and then go on. It's very different from the typical mutex or condition variable. This is mostly for multi-threaded code. It's very common, by the way, in GPUs, these barriers. So yeah, it's like a kind of, this is more oriented to parallelism rather than multitasking. So the threads run in parallel, but I need to synchronize different points to get, I need the result from all the threads at this point, and then I will go on to this point and so on, right? So if I only need one point, I can use a latch, which is it's a new feature of C++20. Yeah.
Yeah. So latches are single use and kind of, fire once and then are ignored, and barriers are when threads should synchronize again and again on the same.
Yeah, can be reset. Yeah, can be reset.
And yeah, then we have a chapter on atomic operations, which is also very useful to have such a book, especially as atomic operations are something which is often overlooked, in my opinion. So let's see. Yeah, here we are, an introduction to atomic operations.
Yeah.
And one of the examples which you had was this SPSC log-free key. Let's take a look at that.
Yeah, okay.
scroll a bit to find it. Here we are.
Yep.
This. And that's something I like about the book, that there's like quite good examples here, which are documented well. And
okay, so the single producer, single consumer lock-free queue, especially a bounded queue, so using a fixed size queue, this is very common in high-frequency trading, for example, to communicate a producer and a consumer. Both threads are spinning all the time, each in its own core, and you avoid the lock. So the threads never blocked, never go to sleep, put to sleep by the scheduler. So the main idea of this is using a ring buffer. So in the book, it's explained why the size was chosen a power of 2, and it's because to avoid doing the modulo. So here you have head +1 and capacity -1. So this is the modulo. This is really a optimized. It's like head +1 modulo capacity, right? So it's a trick. It's a trick. It's a bit manipulation trick to make it faster. Because when we use atomics, when we use these lock-free structures, what we aim for is to minimize the latency. So then it doesn't make much sense to have a modulo operation, right, involving division. That is the worst thing. And then another thing with this queue is that it uses, well, we have two indices, one for the write and one for the read. Both are atomic operations. In this version, in this chapter, you see they are declared as just atomic, and this is improved in a later chapter because doing it this way there's a problem called fault sharing, and we discussed that in a later chapter, and this is optimized, right? Also, this, by the way, the chapter on atomics is one of the most complicated. Atomics is a very complex and deep subject because you cannot isolate yourself, you cannot abstract yourself from the CPU. And the reason we focus mostly on the Intel CPU. ARM is also a good architecture and is more relaxed than Intel. So atomic operations can be faster in theory, but more difficult to write the code. So here you see the memory order. So memory order relaxed, which is because I'm the only thread really changing this variable. I can read it in a relaxed way because I'm myself, there's no problem. So memory order relaxed means I guarantee you the atomicity. So the operation is atomic. And also there is a coherence of writing. What that means is that imagine that we have two threads, thread A, thread B. So thread A starts writing, incrementing a counter with memory order relaxed, 1, 2, 3, 4, 5, 6, and another thread reads it. If both use relaxed, what can happen is the thread B reads 1, 3, 3, 3, 3, 6, 9, but it can never read 1, 3, 3, 3, 5, 4. And never. Once you read the 5, you cannot go back, right? This is one guarantee, the coherency of writes in C++. And then there's another memory order, which is the release. This simplify the meaning is make these changes visible to the thread synchronizing with this atomic variable with memory order acquire, which is the other, which will be if the pop is the consumer, it synchronizes with the producer. Anyway, it's advisable to always profile the code because just using atomics doesn't guarantee that it's going to be faster. In fact, I've done experiments where using mutex was faster. This is very difficult to really have a system where it's going to be faster. So it needs to be, probably we need core isolation and each thread in its own core and it's working at the top of the capacity of the CPU to really be this good. But yeah, this chapter. So by the way, we'll talk about later. I've read about atomics and memory models in other languages also to write this chapter.
True. As I said, it's quite interesting to have examples for these things. And then the next chapter is on promised futures and coroutines. So we're getting a bit more advanced, and we see that here, like you can then read about chaining asynchronous operations and thread safe SBS task keys. It's actually something I've last year started playing around with, like implementing my own thread pool. So
yes, so this chapter 6 is the first of the third part that we enter into the asynchronous world. So before we were talking about multi-threading, now we go to asynchronous programming. So, well, promises and futures is a way to generate expectation on a result, and the future is where you will get that result when it's ready. There are different ways of defining a future. For example, this chapter is focusing on the promises and futures. So you create a promise, and then you get the future from that promise. That creates a channel where the result will be communicated thread safely. So the promise will be running on a thread, and then the future in another thread can get the result. Well, apart from results, we can communicate also exceptions, obviously. So if anything happens, we can get the exception on the other thread and, well, take care of it. About that, also there is this package tasks that is a way to create a function directly and get a future as a result. Yes, that do you have a simplified view of what should be the promise and futures. Yes, and the example that you said about chaining different operations, that is a simple way of defining each step as a function, and you return the future. And in each of the dependent steps, you check if the future is ready. And once you trigger the first step, the result of the first step will be ready, and that propagate to the other futures until reaching the end of the pipeline. So it's a way to build a pipeline, trigger the start point, and get the result at the end.
Yeah, here we are at the thread safe task key 170.
Yes, that's quite similar to the one before, but yes, using promises and features to communicate on the switches.
True. Let's get back.
Yes.
So then the book continues with a whole chapter on the async function.
Yes. So this function is well, I believe it's C++20. To be honest, I don't remember exactly the version, but it's a way to run an asynchronous function. It returns a future, and you can manage whether policies, how they will run, if it will run immediately in the same thread, on different thread, or you defer its execution until the result is required. So the good thing is that it simplifies the way that promises and features are used. So you don't need to think about setting up the promise, getting the future, etc. Well, one drawback that it has, obviously not always will be perfect, is that you cannot cancel the execution. So once it's executed, you need to wait to finish to get the result. With the promises and features, there are some ways to cancel the operation and not waiting for it to finish its execution and then saving resources. With async function, you don't have that. It's a penalty you get achieving simplicity. Yeah, that's it.
Yeah, I found the chapter quite interesting because something it's something I usually don't use in C++, and I think that also I've seen people argue against, because at the beginning async was a bit broken in the implementation, and I think that's fixed by now. And definitely scrolling through the chapter made it interesting. And also kind of like one example I found interesting is limiting the number of threads that you execute through this calling, and the various launch policies which also exist for parallel algorithms. And then we do go into coroutines in the next chapter, which I know has been in the last years a huge and popular topic to speak about and to generally write about coroutines. So how do you cover coroutines in your book?
Okay, so by the way, coroutines in C++, if I remember correctly, this was a Microsoft initiative. And I remember in 2014 or 2013, I was working in a bank, and some people from Microsoft went there to talk about the future of C++ and using coroutines. So this has been in the works for a very long time. So, well, coroutines, by the way, were introduced C++ 20. So the approach is very curious, because when I sat down to write this chapter, I remember a colleague of mine who told me one day, "Hey, I read a lot about coroutines, but I don't understand anything." So I thought, okay, I'm going to try to write something very simple for people to understand how this works. So I think that the main issue with coroutines in C++ is that it's a very low, because C++ really is very low level in general in many things, and they always favor the libraries rather than language, even if coroutines have some language new keywords, the co-yield, co-return, co-wait. Even that, this is very low level stuff, right? So it's really, what the compiler does is, with your help, it generates a state machine and implements this. So it was said that in future releases of C++, probably the library will have more facilities to make this easier. So what I did was, okay, I'm going to start with the easiest, simplest coroutine possible, see all the compiler errors, and start adding what the compiler asks, just to have a full example. And yeah, that was the approach for this. And then a little example of generators, also using the C++ 23 generator. Back then, I think only Clang was supporting it, or I think only Clang supported when we wrote the book. Now, Microsoft Visual Studio also supports it. So yeah, and that was really the structure of the chapter. Something to introduce coroutines in a natural way, and then, because coroutines have two parts. So the coroutines themselves, to implement them in C++, which, as I said, is kind of low level, and then it's the programming with coroutines, which is a different way of structuring your code. So coroutines have been for a long time in other languages. I think Kotlin is one of the most very well supported coroutines. Go is also with the Go routines, and the channels, which we'll can talk a little bit when we talk about Cobalt. So yeah, that was the idea behind this. Not complicated very much. Of course, you can add very complex examples, but that obscures the basics of the new language feature.
Yeah, and as I said, it's like there has been a lot of talking about it in the last years. And now with C++ 2023, I think finally the feature has gotten into a space where it's kind of useful. Then we go into the part 4, which actually goes into the Boost libraries, because often asynchronous programming is done with libraries instead of a standard. and your book covers the Boost libraries and 2 libraries of the Boost selection. And let's start with a chapter on Boost.Asio, which I guess is fairly well known.
Yes, so we decided also, yes, obviously. The Boost libraries, we use them because they are quite used in the industry, in past companies, and the kernel man will also use plenty of times the Boost.Asio because it simplifies the way to write asynchronous code. So Boost.Asio, what it does is you have a execution context that is running on the background, and it handles the thread management and the execution of asynchronous communication with the input-output devices, etc. And it's a nice way to, then in the back, obviously, there is a event loop that is running and managing the events and sending to the user, and user takes care of that. So there are plenty of classes managing typical communications like TCP/UDP communication, access to data, networking, etc. And the examples that we show is how to manage the IO context and creating several threads, or making the work on the same thread, or spanning different threads, etc. So, yeah. I hope you find it interesting.
Yeah, it's Boost.Asio is something I always found interesting, but actually all my career I've never really had like an actual use case for it, because I do not do server code, and always found it very interesting to listen to folks working with it. Then on the 10th chapter, you cover something rather new, the Boost.Cobalt library, which is in Boost since the 1.84 version, which is like 2023. So it's in Boost for almost 2 years.
Yeah. So Boost.Cobalt, I'm not sure if it's 184 or 186. No, I think probably 186. So Boost.Cobalt, yes, is a very new library, and it's trying to do 2 things: to make easier to use coroutines in C++, and also adding some new facilities, like, for example, channels, right? I think like channels, and inspire a little bit in Go. It tries to implement that. So yeah, this chapter is just a light introduction. I think that eventually, I was thinking about contacting the author to help him with the documentation. Yeah, it has nice examples. The examples, no, it's 84, yes, 184. Yeah. So yeah, and the examples are simple. And yeah, this library simplifies a little bit the use of coroutines, but yeah, it's probably very early in its very early stages, and it will be improved, I'm sure. But yeah, has generators, for example. It makes it much easier to write generators. But C++ 23 also has the generator, yes, because it's probably one of the first and most common use of coroutines, similar to Python, right? To the yield.
Yeah.
And so I think that also is an inspired from Python. So yeah, that was the chapter. It's just a light introduction to this, to a slightly different way to use coroutines.
Yeah, it's nice. Then we go to part 5, which I really like, and it shows like that actually your book is also like, not just for people wanting to learn about asynchronous programming, but also people actually working with asynchronous programs. So you speak about debugging, testing, and performance optimization in those chapters. And you start by logging and debugging asynchronous software in chapter 11.
Yes. So this part 5, we thought, okay, so maybe should be nice to also show how to debug software and asynchronous software and also get better performance. So these 3 last chapters talk about that. So chapter 11 is about, well, obviously the first thing when you want to debug probably is to use logging. So you log, you try to parse them and see what's happening. If that doesn't work, because, well, first on the logging side, there are several libraries that you can use. There are some on Boost, and there are many others that they have the advantage on multi-threading or the size of the library, the responsiveness. So we show several of them, and we show some examples on how to log specific areas of the program to detect errors with multi-threading. And then we move to debugging. Debugging asynchronous software is quite complex because you have to unlock the thread that you want to debug, know what thread is being running, place breakpoints and know where to place them, because obviously sometimes might be that the thread doesn't execute that area because another thread gets into it, etc. And a topic that many people thought also interesting is reverse debugging. That is recording a replay of the execution of the program and then going back to the history. So also that is quite interesting. There are some tools and libraries available for that. At the moment, only GDB has this ability on a few of their targets, not all of them. C-Lang is still under development. But yeah, I think it's quite an interesting feature that let's see if in the future is more common and more user-friendly.
Yeah, I noticed like another common term used is time travel debugging, which
yes, time travel debugging, yes.
Have talked with Undo about it, which is one of the commercial debuggers available for this feature. And yeah, this can be, of course, a very, very important part of finding what's going wrong in your programs, to actually see how things play out at runtime and why your programs are not behaving as they should. And time travel debugging and recording of your programs, this is a really, really great ability, which people definitely should look into.
Yes, next chapter. Yes.
Yes, sanitizing. I love that. This is like really, people don't use it enough still, that we have the sanitizers, which is great.
Yes. So, yes, well, sanitizers, I think we should implement some pipelines to detect this kind of sanitizer errors. And if something happens, it's clear that needs fixed, because it can detect memory leaks or, when you do when you have a deadlock or this kind of issues on multi-threading. So there are different kind of sanitizers. Well, some of them doesn't work properly with others. Also, we highlight that on the book, and we show how to use them. So showing the command and also the output, trimmed output, because it's quite long, but it shows the frames and you can from there detect what's happening. So that chapter, we create some small toy examples, really small and really easy to follow, but then we run the different sanitizers and check its output and what is saying the output and what to expect if it's fixed. Apart from that, sanitizers, I think, goes to unit testing in general. For that, we use Google Test. I think it's also one of the most common testing libraries that most of the people use.
Yeah, it's
yes,
the most popular.
And there we explain how to, on a synchronous program, obviously you have threads. So first try to make it synchronous, so testing the synchronous part instead of spanning threads. And also you have to span threads, how to manage in case of something goes wrong with timeouts, etc. So we go with different kind of strategies to try to test asynchronous software. That is not always easy.
Yeah, this parallelizing test gets me curious. But here.
Yes. Well, this parallelizing test is a way to, if the tests are isolated and each test has its setup and teardown process, so you can parallelize them, so running them in parallel and distribute the execution of the test into the different cores, and then you can test the software quicker, obviously, instead of serializing the test runs.
And then the book closes with a chapter on improving asynchronous software performance, which also, kind of is an everyday thing.
Yes. So this chapter, basically we talk about an issue, which is fault sharing, where because of the cache lines 64 byte and the way the CPU work with them, like working with a full line, you have two threads testing two variables, writing to both of them, but they are totally unrelated because of this being in the same cache line. So they are constantly updated, right? So the cache lines, if the threads are in two different cores, the cache are constantly updated, creating a lot of cache hits and worse performance, right? So the log-free queue is improved in this chapter to avoid that, and some other improvements. And also, yeah, this is a simple chapter because we can write a book or two about this performance stuff. But yeah, you see how really the impact of fault sharing is definitely, I think I measured about 30% in this case, but this is very, very, very sensible to the way you use it and how the producer and consumer work and so on, right? But yeah, this is something. And it's a little bit of introduction to the perf tool in Linux. And yeah, some pointers to different resources. Yep.
True. All right. I think that finishes the overview on the book, which actually is quite extensive, going into the topic of asynchronous programming, not just the programming with C++.